Hi, my name is David Follis, and I'm a member of the WebSphere Application Server for zOS development team in Poughkeepsie, New York. This is the second in a series of video lessons designed to introduce you to WebSphere Application Server. Here we will focus on WebSphere Application Server running on the zOS operating system. In the first series, we spent quite a bit of time establishing the concept of open standards, how WAS is WAS at that open standard specification line and above. Here we wish to reinforce that point. We'll draw your attention to how the WAS zOS functions that exploit the zOS platform reside under the open standard line. On the chart, you'll see the stack being built. First, the System Z hardware, then the zOS operating system, then WAS zOS. Then we draw a horizontal line to represent the open standard specification line. Your applications run above the open standard specification line. Those applications see only open standard support. They have no direct awareness that zOS is the underlying platform. That's what we mean by WAS is WAS. At the application layer, WAS zOS looks like WAS on any other platform. Below that line is where the platform exploitation takes place. When we speak of platform exploitation, we're referring to a function implemented by IBM in the WAS zOS product that is zOS aware. It's designed to take advantage of specific features of the platform. This is where a great deal of our focus will be in this video series. We intend to introduce what some of those zOS features are and explain how and why WAS zOS takes advantage of them. Let's begin our exploration of what those zOS features are and how WAS zOS exploits them. So what are some of the zOS attributes that WAS zOS takes advantage of? The first is zOS Workload Manager, or ZWLM for short. ZWLM is a facility of the zOS operating system that closely monitors system activity and resource usage. It controls access to the system resources according to the goals you define to ZWLM. This is what allows zOS to host multiple workloads of differing priorities. WAS zOS makes extensive use of ZWLM. We'll touch on some of the ways WAS zOS takes advantage of ZWLM. We'll save the deeper detail for the upcoming 401 video series. The next zOS attribute we'll mention is cross-memory services. This allows information held in storage for one address space to be very quickly and very efficiently transferred to another address space. This bypasses the communication stack entirely. That means the overhead of the communication stack is eliminated. This also means that data security and integrity is ensured. There is no way to sniff this cross-memory transfer. There's no way to intercept or transform data content. It is entirely secure. The third function is zOS Modify capability. This allows commands to be passed into running tasks. WAS zOS exploits this in two ways. The first is to dynamically alter the runtime behavior of the application server. The second is to dynamically extract runtime information from the application server. Later we'll see some examples of what you can do with the modify command in WAS zOS. The next function is the zOS communication server, which provides the TCP/IP stack. There's a wide variety of configuration options available to make the TCP function very flexible. One feature in particular we'll focus on here and in the next series is the Fricka caching support. Later we'll see how WAS zOS exploits this caching as an extension to Dynacache. The zOS System Access Facility, or SAF for short, is a security interface behind which a security product operates. IBM's product is called RACF. The key message is that SAF provides security function to control access to and usage of nearly every element of the WAS environment. RACF is more than just another LDAP implementation. Finally, zOS provides a comprehensive activity recording facility called SMF. This provides the ability to do post-activity analysis for purposes of capacity planning and chargeback based on actual usage. We skimmed the surface of the why zOS topic at a very high level. If you're interested in exploring further, we encourage you to go to the ibm.com/support/techdocs website and get the WP101532 document. The direct URL is shown on the chart, but the easiest way to access the document is to go to the TechDoc main page and search on the specific document number. Two PDFs will be found here. One is a presentation in chart format. The other provides the charts and full speaker notes under each chart. Let's now turn to look at how the WAS zOS runtime is implemented. We quickly review the key elements of the WAS topology. Remember, these concepts apply across all platforms except where we note they are zOS specific. In the case of zOS, we start with a physical system Z machine. Then we configure a logical partition, and the application server is where your applications run. You may have multiple application servers. The number you settle on really depends on the number of applications you intend to host and the degree of isolation you require between applications. The deployment manager is a special purpose application server that runs the administrative application. The deployment manager also maintains the configuration master repository. Application servers on a given LPAR are grouped into a node, and that node has a node agent. The node agent provides key configuration synchronization activities for the node on behalf of the deployment manager. For zOS, we add a daemon server. The daemon server plays an important role in the WAS-zOS cross-memory services exploitation. It's also where the location service agent is hosted. If you had additional LPARs, you could expand the environment further by creating additional nodes. We implemented WAS on zOS as a group of started tasks. They remain active in servicing requests until they are stopped. The Unix equivalent would be a process. Some of these consist of multiple address spaces due to the split JVM model employed by WAS-zOS. An address space in zOS is a portion of virtual storage that has protection mechanisms built around it. This prevents programs in other address spaces from reading, writing, or otherwise affecting the programs and storage of other address spaces. The daemon and the node agent each consist of only one address space. That implies each runs only IBM plumbing code. Your applications do not run in these server types. The deployment manager has a minimum 2 address spaces with the potential to run more if needed. This is an example of the split JVM model we've referred to earlier. We'll look at this in some detail in this series and in even greater detail in the upcoming 401 series. While the deployment manager is an application server, it is restricted to serving only IBM-supplied administrative applications. Your applications do not run in the deployment manager. Your applications do run in application servers. Application servers employ the same split JVM model as the deployment manager. Therefore, an application server consists of 2 address spaces at a minimum, with the potential to have more if configured. There's one more address space possible with application servers. It's called the Control Region Adjunct. It's what hosts the messaging engine, which is part of the built-in messaging function of WAS. The adjunct only comes into play if the messaging SI bus is configured and a server is connected to the bus to host a messaging engine.